All right, I wanted to take the opportunity to introduce another one of the scientists affiliated with the East River Community Watershed. We're here with John Bargar this morning. It's October 8th, 2017. John, why don't you introduce yourself and tell us a little bit about what you're doing here in East River?
Yeah, hi, thank you, Ken. It's a pleasure to be here always. As you can see from the beautiful scenery, it really makes sample collection fun and eventful. So the SLAC SFA is investigating the impacts of varying water tables on redox conditions within the shallow subsurface, which are extremely important for pumping nutrients vertically up and down within the subsurface, and also metal contaminants. And it so happens that we're standing on exactly such a floodplain now. Here in the late spring and early summer, the water table comes up, and then in the late summer and fall, the water table drops down, and a large chunk of the subsurface transitions from being sulfidic to being oxic and back to sulfidic again. And these large changes have extremely important consequences for stability of contaminant metals as well as nutrients, carbon, nitrogen, lead, zinc. Those are some that we're studying right here. When you change, the most important thing to understand is that when you change from one redox condition, for instance oxic, to reducing, which happens in the late spring, early summer, then you have the opportunity for a large pulse of organic carbon, for iron, and for metals to be mobilized. And in a nutshell, that's what we're studying here. We know now that this particular subsurface here is about 2 meters deep. We see about a meter thick redox active zone where we can see coexisting sulfides and iron oxides, which tells us that we have a lot of goethite sulfide cycling, and this is exactly the kind of behavior that we expect to see, or conditions that we expect to see if we're going to observe this mobilization of carbon, metals, and other critical elements.
Excellent.
I think that's it.
Yeah, no, thank you, John. Tell us a little bit about what you guys have installed here as a part of your work over the past couple of days.
Right, so this is a system of piezometers, and we've also collected pore water here. So there are 3 piezometers here, one at, I believe, 2.5, 2, 1.5, and 1 meter depth. And the idea here is to, and Christian Dewey can correct me if I'm wrong about that, the idea is to basically be able to collect water as a function of depth, because that gives us the opportunity to observe key dissolved solutes that tell us about the redox conditions. For instance, dissolved sulfide and dissolved iron.
Excellent. So let's actually take a quick look for folks here to look at the banks of the Slate River. And so I think everyone will recall that the East River Watershed is composed of 4 primary drainages. There's Coal Creek and Slate River. You're looking at the Slate River here. Both of those are impacted by historic mining activity and naturally mineralized rock, and then Washington Gulch and the East River, which are, by comparison at least, relatively pristine. In the distance, you can see Mount Augusta. It's a fairly mineralized body. We're looking at the Slate River, as I said, just downstream from the confluence with Obi-Joyful Creek. And John, do you want to describe to folks just very briefly kind of the nature of the export of minerals from these drainages?
Oh gosh, you're going to catch me there on that one. So there are a lot of metals that are in this system as a result of hard rock mining over the years, and those metals can be mobilized downstream both directly through saltation and bedload transport, but also through dissolution and mobilization as dissolved solutes. And right now we don't know what are the most important processes for deposition of metals in these floodplains. That's one of the major things that we're going to be investigating next, is what actually is the host form for lead, zinc, and for primarily lead and zinc.
Excellent. Thanks so much. Last thing to note, you've seen videos of our work up in the Redwell Basin and the drilling campaign. So the flow from Redwell Creek that emanates from the basin flows into Obi-Joyful, which then itself flows into the Slate River, again very close to where we're standing. So a lot of connectivity within the watershed, and again affords an excellent opportunity to wrap in a huge number of investigations and investigators and institutions on our work here at East River. Thanks a lot, John.
You're welcome. Thank you, Ken.